Hello again, welcome back to our series of Violodin tutorials. What we're going to do today is have two boards communicate with one another and control the color on this RGB LED. Now what's the deal with this RGB LED? R stands for red, G stands for green, and B stands for blue. This is basically how the color is created on this LED. Since it has 4 pins, you may wonder how you know how to connect it. Basically, the longest one that you can see here goes to the ground, and then each of these other 3 pins has to be connected to a pin controlling its value from 0 to 255, and that actually creates the color in RGB code. So the red pin of my LED is connected here to pin 9, and then the green one is on pin 6, and then the blue one is on pin 3. On the other board, what we have are 3 buttons. So here's button 1, 2, and 3. As you may remember, one of these legs has to be connected through a resistor to the ground. The other one has to go to the 5-volt connector here. And then the first pin also has to get some sort of feedback to our system. And these are connected on pins 2, 4, and 6. One thing I have to specify about this project is that back to our RGB LEDs, they have to be connected on PWM connectors, so make sure that they have tildes there. The pins I have them connected on definitely do. Let's get started with the receiving end first, because I think it'll be easier. So let's create a new application, call it receiving, make sure it's a new visual programming project, and hit next, and then submit. Click receiving here. What you have to remember about this port communication is that it's here under the social tab and port communication. And what we have to interpret is basically when we receive a message that's sent through a particular channel, you may think of these as ports. Something will happen. What we have to be careful with is who the sender of that message is. Now in order to do that, you will notice that I have added 2 of my boards here. So Galileo and board 2. Board 2 will be the recipient for me. So I have to verify that the message is sent from board Galileo, and this is its board ID. Basically, we're going to copy this over, and then close it here. Both of my boards are online, as you can see now. Let's go here to the Program tab, and under Logic, we're going to have a quick test. So here in my variables, I have the sender variable. And under logic, we can compare the two. So if the sender of this particular message is my board ID, the one that I just copied over earlier, then we're going to do something. You don't have to worry about any of these other variables as they're just added there automatically. So what we're going to do is go here under Peripherals and LEDs, and set the color on this RGB LED. Don't worry about the color for now, as we'll get to that later. For now, let's just worry that the pins are set here correctly. So 9, 6, and 3. The label of this particular message will be color. And I also have to make sure that when I create the other application, I'll send it under the same label. Okay, let's take care of the sending end as well. So sending will be another application that's built under visual programming here. Click next and submit. Find the sending application here. The part where I'm sending the message will be right here. So under social and board communication, I'm going to send a message to the other board. We have to get the board ID from here. So board 2 has this particular board ID. Under sending here, I'm going to insert this board ID, and the message will be something special you'll see later. Its label will be color. Okay. What I'm going to send over on the other end to the other board, which in this case is in the same room, but it may well be just across the street from me or on the opposite side of the planet, will basically be a color. Okay, which is created using 3 variables, red, green, and blue, which I have to instantiate here. So create 3 new variables. Call one red, the other one's green and blue. These will first be just 0, so we have to add this to the beginning of our program, and then go back to the variables tab and add red, green, and blue from this tab here. Now, as you notice, you don't have to worry about any of the way in which these are encoded. You just send a message and this sends out the color, which is being interpreted here. So under set find color, you basically have to add the message. That's what we receive over here. Okay, now let's get to how we can create this RGB code. What I'm going to do is test for when each of these buttons is pressed and then change the color red, green, and blue for each of these buttons being pressed. So I'm going to have a loop first of all, repeat this every 100 milliseconds so that it's very responsive, and do a quick test. So if under sensors here and buttons, the button on pin number 6 is pressed, this is the one that's associated with the color red, I'm going to do something and then I'm going to send a message. Basically what we're going to do here is add another quick variable when we first run the program, which is going to be called updated. That way I'll be able to test whether anything has been updated so that I don't send too many messages between the boards. Initially, that will just be false, as nothing has been changed. So basically, when the button on pin 6 is pressed, I'm going to go here under the variables tab and set the red variable to, and this is where it gets interesting. I'm going to take the initial variable red and increase it by an amount. I'll add another quick variable here, which I'm going to call step, so that it increases in various steps. And I'll just set that to 10 for now. So once again, the codes that we have to send go from 0 to 255. So basically, we're going to increase in steps of 10. But at one point, we're going to get to 255, so we need to check for that. How we're going to do that is go back here to Numbers and Math, and then find the block that says Remainder of. We're going to add that here instead of this one. Add the quick variable called step to my red code, and then divide that by 255. So whenever it switches above it, it'll just move down, and the value will always be between 0 and 255. Once we do that, we'll just set updated to true. And then, at the end, we're going to have another quick logic which says, if something has been updated, send this message. So just go back to variables, and because the variable updated is either true or false, we can just add it here. So say if updated, then send the message. We're basically going to, oh, sorry, this was wrong here. We're basically going to do this in exactly the same way for green. Okay. And make sure that you change the pin here to pin number 4. And then the blue pin here. On pin number 2. Last but not least, make sure that after you do this, you set the updated variable back to false. Otherwise, this will constantly be sent. Okay, so let's see how these two behave. So this is my sending application, which I'm going to have to deploy in my Galileo, and my receiving application will have to be running on board number 2. As you can see, I'm just going to press the button that's associated to red here, and then my LED should turn more and more red, which it is. I hope you can see this correctly. Okay, then we're going to switch over to the green, and then green will become the dominant color, and then blue will make everything turn more and more blue until it turns actually white, or white-ish. And at the end of this, as you can see, it reset on the blue and it moved back to the green. Okay, hope you have fun communicating between boards and changing this RGB LED.